Okay, welcome to lesson 8, representing proportional relationships with equations. We kind of touched on this with the heart rate activity, but let's get into it a little bit deeper. We're going to want to remember relationships have a constant ratio or unit rate. Okay, the constant ratio or unit rate, it can be described as y divided by x. It is also called the constant of proportionality. In other words, our COP, our COP, keeps things in order. How could we use what we know about the constant proportionality to write an equation? Well, let's think about what we remember and also the points to remember that were just given to us. The COP is K. And what do we know about K? K is equal to y over x, which is y divided by x. Y and x are ordered pairs. The COP is also the unit rate. Now, let's try to use all this information to develop what we know as the equation of a line. If I wanted to solve for y, and I already know the variable x, what equation can I use to solve for y, right? Well, I want to solve for y, so that means it has to equal y, and I know the variable x. Then I need to multiply x by the variable k, which is our constant of proportionality. This right here represents a proportional relationship. Okay, so let's keep that. This equation is going to be the staple of our lesson today. So example 1, do we have enough gas to make it to the gas station? Your mother has accelerated onto the interstate, beginning a long road trip, and you notice that the low fuel light is on, indicating that there's a half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. You know that if you can determine the amount of gas that her car continues in a particular number of miles, then you can determine whether or not you can make it to the next gas station. Okay, let's part A, find the constant of proportionality, what it represents in this situation. Okay, so the constant of proportionality, we got to remember, is our unit rate. And our unit rate is K, which is y divided by x. So let's assign our variables. Let's call gallons x and miles driven y. Okay, because gallons, you need gas before you can drive. So x comes before y. And let's write out K is equal to y over x. Which is also the same thing as I'm going to use actual variables for these. That way you can be able to plug it in easier. You don't have to remember what is y versus what is x. So we see that g is x. It's on the bottom, and y is m. Okay? So let's look back at our problem. So we need to find the constant proportionality, which is also, once again, our unit rate. So let's plug it in. So m over g. So let's do 224 divided by 8, which simplifies to 28. Once again, m over g is equal to 280 80 divided by 10, which is also equal to 28. And then we also have our last formula, m over g. 112 divided by 4, which also simplifies to 28. So we can say that our COP, or our constant proportionality, is 28 miles on a gallon. Okay, now write equations that will relate the miles driven to the number of gallons of gas. So once again, we use the formula y equals kx, and we already know that y is m, and x is g. Okay, and let's plug in our information. K is also equal to 28. So we're going to say m equals 28g. We can use this equation to determine for any amount of miles or gas. So this is going to be our staple to solve the rest of the problem. Knowing that there is a half a gallon left in the gas tank when the light comes on, will she make it to the nearest gas station? Explain why or why not. Let's go back to our word problem. It says that the nearest gas station is 26 miles away, and you need an entire gallon to make 28 to travel 28 miles. So my conjecture is no, because 1 gallon will get her to go 28 miles. But with only half a tank left. She can only travel 14 miles when she needs to travel 26. Using the equation found in part B, determine how far your mother can travel on 18 gallons of gas. So the information found in part B is our equation. I'm going to go with m is equal to 28g. Okay, so 18 gallons of gas, so I'm going to replace g with 18. Therefore, m is equal to 504 miles. Your mother can travel 504 miles on 18 gallons of gas. And using the constant of proportionality, once again our unit rate, and then using the equation found in part B, determine how many gallons of gas would be needed to travel 750 miles. So our constant of proportionality, let me remind you, is K equals 28, and our formula is M equals 28G. So it told me 750 miles, so I'm going to replace M with 750 miles. So therefore, that's going to translate to 750. M is equal to 20, not M, sorry. 750 is equal to 28G. And we're going to solve for G, divide by 28 on both sides. And G is equal to 26.8. Okay, perfect. Now, let's summarize that, sorry. 26.8 gallons of gas would be needed to travel 750 miles. All right, so now we're going to go ahead to example 2. Okay. Andrea is a street artist in New Orleans. She draws a caricature, cartoon-like portraits of tourists. People have their portrait drawn and then come back later to pick it up from her. The graph below shows the relationship between the number of portraits she draws and the amount of time and hours she needs to draw the portraits. Okay, and let's make sure we understand that this represents hours. Time is usually X, okay? I'm not sure. Now, write several ordered pairs from the graph and explain what each ordered pair means in the context of this graph. So I'm going to pick some points. I picked the points that are in little crosshairs, the ones that you can find easily, like these. What I mean by crosshairs, I mean like right on the center of the line. So right there. So the points that I have discovered are 2, 3, 4, 6, and 6, 9. And what they all mean, this one means, I'm just going to do this first point and you can go ahead and fill in these last two yourself. When Andrea spends 2 hours of drawing, she produces 3 caricatures. Have to pronounce it out. Caricatures. Okay, you can go ahead and do 4 and 6 and 6 and 9. Pause the video and do those before moving on to part B. Now, this one asks you to write several equations that would relate to the number of portraits drawn to the time spent. So in order to find my equation, I'm going to start with K is equal to Y over X, which is equal to, using your points, I'm going to use my points 2, 3. Y is 3. X is 2. So I'm going to get 3 halves. Now, if I were to simplify 3 halves or divide it, I would end up with 3 different values. So I would have 3 halves, or 1 1/2, or 1.5. So I end up with K equals 3 halves X. K equals 1.5 X. And K is equal to 1 1/2 X. These are all considered unit rates. Now, why is it a considered unit rate? Well, if I wanted to simplify 3 halves to have, let's say, a unit rate of, let's not use 3 halves. Let's use, well, actually, no, we can do this. I want to do this to get a unit rate of 1, right? I'm going to divide by 2. So what's 3 divided by 2 equal? 1 1/2, or 3 halves. So let's write it as 1 1/2 so you guys can see that, 1.5. I can easily see that 1.5 over 1, that's my unit rate. This is what we call a complex fraction. When you have a rational number when a fraction is also in the numerator. Now, this could also be written, remember, as, let's say, 1 1/2 over 1. So that's what I mean by a fraction in the numerator, or 3 halves. Now, determine the constant of proportionality. Explain what it means in this situation. The constant of proportionality is 1 1/2, which means that Andrea can draw 3 portraits in 2 hours, or complete 1 1/2 portraits in 1 hour.
That is all for this video. There are no problem set questions or exercise questions to be completed at this time. Thank you.